Classify each equation as linear, quadratic, or exponential. So when we go back to our notes, we remember that part A was telling us how to classify the equations. So linear has an x but no exponent. Quadratic has an exponent of 2 in the equation. And exponential means that x is the exponent. So I'm just going to quickly jot that down so that I can remind myself. So linear is x to the first power, quadratic is x to the second power, and then exponential is x is the exponent, right? So let's do these one at a time. For part A, f of x equals 3x plus 2. Remember, f of x is function notation. It's the same thing as saying y. So you can use f of x and y interchangeably. They mean the same thing. We'll talk more about that, though, when we get to function notation. So 3x plus 2. Well, the x is not in the exponent, and it doesn't have an exponent of 2. It has an exponent of 1, right? There's like a little imaginary 1 there. So that means this is linear. For B, we notice that x is in the exponent, so this is exponential, right? If it's in the exponent, it's exponential. F of x equals 2. Well, in this case, y equals 2. This one's kind of confusing. If we graphed this, y equals 2, we would go to the y coordinate of 2 and draw a horizontal line. So what this means is that this is a straight line. It's just not in y equals mx plus b form. So we'll call it linear. I would have also accepted, though, if you had said neither, because it doesn't follow the rules that we've written down. For part D, x is in the exponent, so it's exponential. For part E, x is in the exponent, so it's exponential. And then for part F, we have an exponent of 2 attached to x, which means this is our only quadratic function that we're going to see on this slide.